Good morning, class. Welcome to this lesson on Geometric Optics 9, Converging Lens Ray Diagrams. So today we will be able to draw the three ray diagrams for a converging lens. And before we start off, I would just like to say that these ray diagrams are going to be very similar. They're going to be very similar to mirror diagrams for a concave mirror, okay? So it's almost really good for you to be able to know these first, because if you understand the mirror diagrams, the lens diagram is going to be very easy. And to study these together, because if you know one, it's very simple to know the other. And I would like to remind you again that when you're doing these ray diagrams, especially on a test, especially the AP test, use a ruler. Use a ruler because you're just going to get a more accurate diagram, which will help you with your answer. Because if you have a bad picture, it's not going to make sense. Okay, so um, know your mirror diagrams as well as your converging lens ray diagrams. So there's going to be three rays we're going to draw. Okay, three rays. Our first ray is going to be this one. First ray is going to be parallel to principal axis, and then we'll go through the focus, or the focal point. So you can see in this picture above me, hits the mirror, goes to the focal point. Ray 2 will go through focal point and then move parallel to the principal axis. Okay? So you can see here it's going through the focal point on the left-hand side as opposed to the right-hand side, hits the mirror and then moves parallel. And the third ray is going to move right through the middle. Move right through the middle. Straight line. And how does that work? This piece in the middle is like having a rectangular piece of glass. This is like having a rectangular piece of glass, and we know from refraction that if a ray hits a rectangular piece of glass, if it moves into the glass at say a 20-degree angle, from the normal, 20-degree angle, okay, it's going to bend towards the normal, like that. And then when it hits the normal right here, it's going to bend back away at 20 degrees. So when a ray goes into a rectangular piece, it will leave at the exact same angle that it comes in with. And so you can see here, there's actually a shift. If I draw some lines here, there's actually a shift in the distance here, but because this is a thin lens, we can pretty much assume that there's no change. There's no shift from one side to the other. There is a little bit, but not enough to make a difference, okay? And just like I said before with mirrors, you only really need to draw two rays. You can pick which two you want to do, but you really have to draw two rays to get your image. And most tests and most people will accept two rays only. And so my first diagram, I'll draw all three, and then I will do just two because it's just simpler that way. Okay? So here is our first converging lens, and you can see below this I drew the mirror diagram for a concave mirror because I'm going to show you how similar it is afterwards. Okay? So let's draw our first ray. Our first ray, let me get my nice tool here. Our first ray, we'll do blue, is going to start off at the point. It's going to be parallel to the axis. It's going to hit in the middle, and then it's going to hit in the middle and go through the focus. And you can see here that we have the focus and we have, remember the center of curvature? We have the center of curvature or the radius of curvature, and we know that it's 2 times the focus. So it's the same thing for lenses, okay? So that's our first ray. Our second ray is going to go, let me get my object here. Our second ray is going to go through the focus, and then it's going to move parallel to the principal axis like that. And our third ray is just going to go right through the center. Okay, just like that. And you can see here, our object is going to be right there, and it's going to be an arrow that is upside down. Okay, so what do we know about this? It is, so if we have an object that is beyond 2f, so you can see here's 2f, it's beyond 2f, it is going to be three things. It is going to be smaller. It is going to be a real image, not a virtual image, and it's going to be inverted. Inverted. And look at our mirror diagram down here. In our mirror diagram over here, we have a smaller image that is real and inverted. If we took just this section right here, this kind of triangle looking area right here, and flipped it to the other side, it would look just like this. So, I mean, if we punched in the numbers, if the focal length was the same for this lens as it is for this mirror, if the focal length was the same and the object height and the object distance were the same, we would get the same numbers if we plugged it into our equations for the lens as we would for the mirror. So I'm just trying to show you how similar these two are. If you know this one, you know this one, but instead of the light reflecting back, it's going to refract and come on the other side. So very similar. Our next ray diagram is going to be within 2f. So this is, or excuse me, between f and 2f. Okay, between f and 2f. And so let's draw this ray diagram now. And now I'm only going to draw two. Okay, I'm only going to draw two this time. So we'll do blue again. We're going to draw our first one parallel to the principal axis, and then through F. Our next one, I'm just going to draw, I think it's the easiest one, just draw a straight line through the middle, through the center point, like that. And as you can see here, our image is going to be right here. So if it's between F and 2F, the image is going to be larger, real, and inverted. Okay? Just like with our mirror, the image is, if it's between C and F, the image is going to be larger, real, and inverted, just on the opposite side. Okay, so once again, if you know mirrors, you know lenses. I'm just going to keep saying that over and over again. Okay, if it's within F, so now we are within the focus. Within F, so we're closer to the mirror than we are to the focus, or we're closer to the mirror. We're within F. Our first line is going to be parallel to the principal axis, and then it's going to go through F, like that. And our second line is going to go through the center, like that. And as you can see, neither of these lines will meet. Neither of these lines will meet. So we're going to draw their extensions of the reflections here. And so we can draw a line like this. That is pretty much parallel or in line, and this is going to come up like this. And so we are going to have an image right here. And so if we are within F, the image is going to be larger, virtual, and upright with respect to the object, okay? I think I made this point before, but I'm going to make it again. Upright means that they are directly related. So if this one is up, this one is up. If this one is down like this, then the image would be down as well. Okay, so it doesn't matter if they're actually going up northward or going down southward, like in this diagram here. But it just matters that they are on the same side. So, and as you can tell from the mirror diagram here, our image is larger, it is virtual, and it is upright. So like I said before, if you know mirrors, you know lenses, and that is drawing ray diagrams for lenses, for, excuse me, converging lenses.